Rajeshwari MG. She pursued her BE in Electrical and Electronics at the People's Education Society College of Engineering, Mandya. She pursued her MTech in VLSI Design and Embedded Systems at the Sri Jagadguru Balagangadharanta Institute of Technology, Bangalore. Her personal skills lie in good verbal and written communication skills. Her areas of interest lie in OOPS with C++, renewable energy sources, HVDC transmission, digital relays, automotive electronics, advances in VLSI design. She has also had papers presented at the national level, such as the Innovative Architecture for SoC Multi-Core Hybrid Processor, presented at the RNSIT, Bangalore.
Welcome to UGC lecture series of BSc Applied Electronics. Today we are dealing with the subject television and engineering. Some of the topics that we are going to discuss in unit 3 are television receivers and its types. There are different types of television receivers are there that we are going to discuss in television receivers part, and next is the block diagram of monochrome receiver. That is in detail that we are going to consider only that black and white television system and its block diagram in detail, discussion of all the blocks in the receivers of a monochrome system. Next, at the last topic is choice of intermediate frequencies. In the intermediate frequency, we need to make certain things should be considered before choosing an intermediate frequency. There are plenty of things that we need to consider, but in this session we are going to concentrate on image rejection ratio. Let us start with the first topic, television receivers and its types. Television receivers, we already discussed in the previous session. The receiver signal contains two types of signal. One is picture signal, that is amplitude modulated picture signal, and sound signal, that is frequency modulated sound signal. So, in the receiver part there should be amplitude modulating receiver and also frequency modulating receiver for picture and sound respectively. So, these are the two things we need to remember in a receiver. And also one more thing, in addition to this, there are plenty of other blocks also required, like suitable scanning circuitry should be there, synchronizing should be there, and also there should be a picture tube for reproducing the picture that is transmitted from the transmitter. These are the things that we need to concentrate in a receiver section. So, next we move on to types of television receivers. Actually, there are three types in a television receivers. Very first one is a tubes, where all the elements in the receiver part will be made up of tubes only. That is all the stages, like whatever we consider the transistor that we are now using, all will be replaced in very olden days as a tube forms. So, after that it is evolved, the tubes are extended and all the devices are used by solid states or transistors are also used with the integrated circuit. This is the second type, where we are going to use solid state devices, transistor, integrated circuits, that is the second type. And next third type will be a combination, it is a hybrid form of tubes and along with the transistor, that is called as a hybrid receiver. So, this is how the receiver is evolved from us using only tubes to till we are using only the transistors. So, in the picture we can easily recognize some of the parts of a receiver section. This is where the receiver sections, the back portion is removed, all those parts will be easily visible. So, this is the first main part, that is called as a picture tube, where we can get a picture. This is the power supply and this is a yoke of a picture tube, and this is where video and audio output circuits are present, and this is a sync and vertical deflection circuit, and this will be vertical, that is vertical line output, that is from a transfer. This is a transformer where we get a vertical line, that is scanning line for the deflection of vertical scanning pulses. Next is a damper diode will be there here, and another thing is horizontal output and horizontal EHT, that is extra high tension section. This will be useful in some of the CRT tube like receivers, and some of the parts vertical hold, these are the control that we already discussed. There is a control knobs that usually placed in a front end panel of a receiver section. This is contrast knob, brightness, on off volume, vertical hold, and this is an important thing, that is VHF tuner, from where we are going to tune for a particular channel, where the VHF stands for very high frequency tuner. This is loudspeaker for audio output. And another picture which is clearly shows all the parts in a brighter manner. We can easily find out the yoke, the picture tube here, the different, these are called as a different tubes, that is what we are called it different tubes, and this will be the transistor, that what I already said, and some of the supply, and this is the knob, and this is the loudspeaker, these are the knobs, and this is a loudspeaker for audio output. This is how the rear view of a receiver in a black and white system is visible. Now we are going to discuss in detail all three types of receiver. The very first that already said is all tubes, where all the elements are in a monochrome receiver are having a tubes, and which is going to serve for a several multi-purpose activities, and these may be of number 12 tubes may be considered in some of the receiver. And in this tube type receiver, the DC supply that we are going to give for this all tube receiver is of 140 to 280 volts. Next is a solid state receivers. All states except the picture tube uses a semiconductor diodes, except the picture tube, that all the things other elements are going to use with the semiconductor diodes, transistors and integrated circuits. And here the DC supply will be of 100 volts. And one more additional thing is here, the heater power. The heater power to the picture tube is also supplied, and that is supplied with a separate filament transformer. The next last type of receiver is hybrid receiver. In this type, all the deflection circuit generally used for power tubes, while the signal circuits use transistor. So, the deflection circuits generally consist of power made up of tubes, that is the horizontal or vertical deflection coils will be there. No, all these circuit will be of made up of tubes, and another the remaining the signal circuit will be there, that circuit will be used with the help of transistor and also integrated circuits. So, all these will be having a line connected power supply with a series heaters of tubes. So, here there will be a series of heaters will be there in a hybrid receiver, and also one more important difference between hybrid and the previous another two receiver types are, there will be two DC sources, one for semiconductor devices and other for tubes are provided separately, for one for signal circuits, another for tube circuits will be separately given as a supply, DC supply. Next we move on to another topic, the block, which will going to explain in detail about the monochrome receiver. So, in the picture we can observe the, in the block diagram we observe in detail the monochrome receiver blocks. All the blocks will be present here. Let us start with the very first block, that is the RF section. This dotted line box is called as RF section, where the antenna, having two types of antenna will be there. One is UHF antenna, another one is VHF antenna. Sometimes the signal will be in the range of UHF, in some other time it may be in the range of VHF. So, we need two different antenna to trap these two types of signal. So, UHF stands for ultra high frequency and VHF stands for very high frequency. When the signal is trapped from the antenna, it is sent for the mixer, where the mixer is mixed with the super heterodyne will be formed, that is mixed with a different frequency signal, and this will be sent to the radio frequency amplifier. Radio frequency amplifier, where it will going to amplify the signal from the antenna and it is sent to the mixer again. So, in the mixer we need to tune for a particular channel, right? That has to be done from the local oscillator in the receiver part, which is going to set by a manually. So, by selecting a different frequency, we can discuss this part in detail in upcoming slides. A local oscillator will give tune for a particular frequency, and this will be sent to the mixer. In the mixer there is some subtraction will going to happen. So, we will get a signal, that signal will going to send to the video intermediate frequency amplifier. Already we discussed in the previous unit, the video amplifier will be having 2 to 3 stage, or sometimes it will be having of 5 stages for better amplification of the input signal. So, this has to be amplified and it is sent to the last video intermediate frequency amplifier. So, here again it is sent to the video detector. Till here we have retained the same video signal that what we got from the antenna, but it is slightly modified and refined with the help of all other 4 blocks, previous blocks. So, in the video detector, the major part of video and the audio will be detected, and video will be sent to the AGC, that is amplitude gain control circuit back, and again it is amplified in 2 or 3 stages. So, again in the video detector another signal that we found is sound, that is sound signal. It is sent for the trap circuit which is having 5.5 megahertz. Why it is 5.5 megahertz? Everything we will going to discuss in the upcoming slides. So, this is the standard one that we need to have the intercarrier frequency, that is 5.5 megahertz. So, here the sound signal is trapped and it is sent with the FM intercarrier sound signal to the sound intermediate frequency amplifier. Again it is sent to FM sound detector, then it is sent to audio voltage amplifier where it is amplified and it is also AM modulated. Again it is sent to audio amplifier and finally sent to the loudspeaker where we got the audio output. So, here we left over with the audio signal processing. So, after the video detector we got a sound signal separately and the video signal separately. The video signal, this is sent to the video amplifier and it is sent for the series of process. It has to be carried out series of process. The first is sync separation. The sync separator is a circuit block where all the sync, what are the sync signals? That is horizontal sync pulses and vertical sync pulses, and also the equalizing pulses had to be separated in the sync separator. So, here we got a vertical and horizontal sync pulses separated and it is fed to the automatic frequency controller, then to the horizontal oscillation for which has to be oscillated in the frequency of 15,625 hertz. Again it is sent to the horizontal output amplifier and finally it is sent to the picture tube with the EHT rectifier. And here the vertical also having sent to the oscillator and is sent to the vertical amplifier and finally sent to the yoke where horizontal pulses will helpful for a field, vertical pulses will be end for a field end and horizontal pulses are end for a line. So, this is the block diagram and each block will going to perform different actions and all are important in a receiver section. Next we move on to antenna. In detail we are going to discuss each part. This is the strongest signal in and it is having antenna, always it is mounted as a horizontal. For a favorable signal to noise ratio, the antenna should be always kept in a horizontal position, and whatever the signal that were transmitted, that has to be trapped in the same polarization in the receiver part also. And for good signal use we need a tuned antenna also. For tuned antenna will get a better signal. And for channel selection we need VHF band, a half wavelength antenna would be necessary for this. So, various antennas will be there. One type is dipole type, with it is having a reflector and directors in width. So, a Yogi antenna is another type which is having a dipole with one reflector and 2 or more directors, which is a compact high gain directional array used in fringe areas. So, in areas where in some part of areas there will be less strength and in some part of area there will be more signal. So, where the signal strength is low, we need to use a booster amplifier with the suitable matching network. Where the signal strength is high, various types of indoor antenna will be there, those will be used in the areas where the signal strength are high. So, when the dipole antenna is used, it is going to cover with both upper and lower VHF band channels and high and low band dipoles connected to the common transmission line. So, all these should be connected to the common transmission line. For channels in the UHF band, attenuation is very high for the channel in the range of UHF rem. So, all the signal reaching are weaker here. A special antenna like fan dipole, rhombic and parabolic reflector type are often used for as a antenna for a UHF band signal. Next, the transmission line connects antenna to the receiver input terminals for the RF tuner. So, the transmission line connects antenna to the receiver input terminal for the RF tuner. The current practice where the transmission line, all the transmission line that are used in a TV receiver are of 300 ohm. That is what the current practice, that is what we are going to use in the receiver, that all the transmission line is of 300 ohms. Next, a receiver designed to receive UHF channels have two inputs, one to match a 300 ohm transmission line and other for 75 ohm coaxial cable. There will be, it is designed to receive UHF channels, that is having two inputs. So, and another thing, a signal strength of the order of 500 microvolt to 1 millivolt and a signal to noise ratio of 30:1 are considered adequate for satisfactory reception. These are the two things that we need to consider while receiving a signal, that is the 500 microvolt to 1 millivolt of a signal strength and a signal to noise ratio of 30:1. Next, we move on to RF section. This is consist of RF amplifier, mixer and local oscillator, and it is normally mounted as a separate subchassis, that is called as front end or RF tuner, and here the tubes are transistor used for a RF section. With the tubes, local oscillator and mixer functions combined in one stage, that is called as frequency converter. The purpose of the tuner unit, it is going to amplify both the picture and as well as the sound signal, and it is going to convert this signal into a carrier frequency and their associated band. So, in the RF tuner, the output that what we got is consisting of both the video and also the sound signal will be there, and also it consists of carrier frequency along with the side bands. The receiver uses super heterodyne principle, that is it uses frequency mixing to convert all the signal that is received in the tuner, and it is convert that signal into a fixed intermediate frequency. Now onwards we are going to use as IF. The signal voltage or information from various stations modulated over different carrier frequencies as of all heterodyne type. So, whatever the signal that we got, which will going to in the form of heterodyne type. So, in the mixer we are going to mix with a different frequency signal, that is called as intermediate frequency, that is what we got from a mixer output. Setting of the local oscillator frequency enables the selection of desired station, that is what, when we got the output from an oscillator, the signal frequency should match with the station frequency, then only we will get a particular channel or desired channel. The standard of an intermediate frequency for 625B system are IF is equal to 38.9 megahertz, that is for picture intermediate frequency will be 38.9 megahertz. This is for standard 625B system, and sound intermediate frequency will be 33.4 megahertz. So, tuning will be different for different channels. Keeping in the mind of this standard, we need to tune the oscillator for a particular frequency to get a desired channel. Next, we move on to block diagram of a VHF tuner selector which set for a channel 4. If we set for a channel 4, we need to tune the local oscillator for a particular frequency of 101.15 megahertz. This is tuned with the help of fine tuning knob, and we will get a 101 megahertz frequency. From the mixer we will get a output of sound, that is, this is what sound standard for a 625B intermediate frequency signal, that is 33.4 megahertz. The required intermediate frequency are then produced, that is looks like this. This is ideal response curve of a radio frequency amplifier when set for channel 4. This is what we get from the channel 4, 62.25 to 67.75. This is the sound carrier frequency, this is the picture carrier frequency of a channel 4. So, the bandwidth of this channel will be 7 megahertz. So, here we need to get from a mixer would be the standard 625B sound and picture signal. So, how we need to calculate means the local oscillator frequency should be 101.15, that is minus picture carrier frequency will give a standard 38.9 megahertz picture intermediate frequency. Similarly, for the sound 101.15 megahertz minus 67.75 carrier frequency of sound is equal to sound intermediate frequency, that is 33.4 megahertz, which is a standard for 625B. This is how we can tune for a particular frequency by changing the frequency of an oscillator. From this explanation we can clearly note down that by changing the oscillator frequency only we set the channel for a particular frequency, then we can go for a desired channel. So, the desired output response from the mixer is shown here. This is what the output from the mixer, that after we getting a standard 625B sound intermediate frequency, that is 3.4 megahertz, picture will be 38.9 megahertz with a bandwidth of 7 megahertz. The frequency changing process reverse the relative positions of the sound and picture signals here. We can observe here. Here the carrier picture frequency will be comes first, but here the sound intermediate frequency will come. So, this is what the difference from oscillator output as well as the mixer output, it will be reversed in the both output. Next, we move on to some of the topics that how the oscillator works. The oscillator works will be of having a signals with the different frequencies, and the different frequency will be produced when the picture and sound frequency are subtracted. That is what we discussed in the previous slide. With the help of mixers, the oscillator signal output will be given to the mixers, where the subtraction of the oscillator frequency and the station frequency will be done to get a standard intermediate frequency. It may be noted that the picture and sound signal would remain in the same relative position, which is always related in the same position, that is with the sound carrier frequency higher than the picture carrier frequency. If local oscillator frequency is set below instead of above, the local oscillator frequency is kept always higher because of ease of oscillator design and several other merits will be there. That is why the local oscillator should be higher than the carrier frequency. Next, we move on to IF amplifier section, which is having a short length, that is having a coaxial cable that feeds the tuner output of the first IF amplifier, and it is also called as video IF amplifier. Consists of composite signal which consists of modulated picture IF signal in the IF amplifier. All the gains and selectivity of the receiver is provided by a IF selection only. That is, by changing the gain, the amplifier function is also changed. By changing the gain, the video amplification also will be changed. There are many stages like 2 or 3 or 3 to 4 or 2 to 5 stages will be there, that is needed for a different types of receivers, and integrated circuits also used here in IF amplifier circuit, and one IC chip contains all the IF amplifiers stages. Next, what are the essential functions of the intermediate frequency section? This is important. We need to note some of the important things. The main function of this section is to amplify the modulated intermediate frequency, that is what the IF section will do, and over its entire bandwidth with an input of about 0.5 millivolt, that is very less voltage, from a mixer to deliver about 4 volt. into the video detector that needs an overall gain of about 8000. They look at this observation that gain should be of more, that is 8000 should it has to reach. So, gain adjusted by automatic gain control AGC or a wide range to accommodate input signal variation of the antenna from 50 microvolt to 0.5 volt to deliver about 4 volt peak to peak signal at the input of the video detector. So, we need to adjust the gain to get these output, so which will be helpful for us in the further process. To achieve desired gain, there should be at least, this is the minimum requirement, that is it has to be considered the 3 stage of tuned amplifier, that is in a cascaded manner. To obtain desired bandwidth, the resonant frequencies of these stages are also staggered. So, there should not be any kind of resonant frequency to get the desired bandwidth, and such these by selecting all these can be achieved by providing desired gain selectivity. We need to select a particular gain to achieve a desired bandwidth. So, choice of intermediate frequency depends on these factors. One is image rejection ratio, another one pickup due to local oscillator radiation from TV receivers, ease of separation of modulating signal from intermediate frequency carrier at the demodulator. But in this session we are going to concentrate only on the image rejection. This how this factor will going to affect on selecting a intermediate frequency. Let us see. Very first thing, the image rejection means it is the ratio output of a station signal to a output of an image signal. It is the ratio of a output of a station signal to the output of an image signal. This is called as an image ratio. The image frequency should not lie in the FM band. So, the FM, if it is lie in the FM band, there may be interference and we won't achieve the proper output. So, the interference are direct pickup from bands assigned for the other services, and also the gain. So, image frequency should not lie in the FM band. This is another point for a choosing intermediate frequency, and interference are direct pickup from bands assigned for other services. This is another thing that we need to remember for selecting IF. And last one is a gain. As I said, the image ratio, it is defined as a ratio of a signal output from a station signal. It is a ratio of a signal output of a station and also output of an image signal. This gives a image ratio, and it has to be maintained a particular value so that we can avoid the interference in the signal. For a desired input signal at 100 megahertz, the local oscillator frequency is set to 110 megahertz. This we consider as an example to know better about image rejection. If the IF frequency is fixed at 10 megahertz, what will going to happen? So, 10 will be going to megahertz, 10 megahertz will be what we are getting from a mixer. For the same input, that is for the same 100 megahertz frequency, if the intermediate frequency is chosen to be 40 megahertz, so the local oscillator must be set to an output of 140. So, 140 intermediate means we need to set the local oscillator for 140 megahertz. It is 10 megahertz, we need to set a 110 megahertz for a local oscillator. This will clearly explain how we consider the local oscillator signal. The local oscillator signal frequency will be 110 megahertz here. From the mixer what we get is the 10 megahertz. This is the intermediate frequency for a desired signal of 100 megahertz. The same 100 megahertz is considered in this example also with 140 megahertz local oscillator output, and what we get 40 megahertz as a intermediate frequency. This example we also consider if another case, that is if the station is operating at 120 megahertz, it will also be received, and also the local oscillator will going to have a frequency of 110 megahertz same, and also it develop the mixer output will be 10 megahertz, no change in anything. Similarly, in the second case, if the station is operating at 180 megahertz, this will going to affect, so will be received equally, but output circuit of a mixer is tuned to the delivered output at 40 megahertz, that in each case the undesired signal which gets received is spaced at a gap of twice the carrier frequency, that is known as a signal image, that is known as a signal image. That is, in each case we are going to space the gap of twice the intermediate frequency. Let us have a quick summary. In this session we discussed about television receivers, and it is having different types of receiver, that is tubes, all tubes and all solid state devices, and also hybrid receivers. We already go through the in detail of block diagram of monochrome receiver. Some of the questions regarding this session are: what are the different types of television receivers? Explain the block diagram of monochrome television receiver. Mention the essential functions of the IF section. Which are the factors that influence the choice of intermediate frequencies in TV receivers? What is an image ratio? How does it affect on intermediate frequency? These are the questions, and the references are engineeringtv.com, tvtechnology.com. These are the website reference, and the textbook are Basic Television Principle and Servicing by Bernard and Grob, and another textbook, Television and Video Engineering by A.M. Dake. This ends the session. Thank you.